All right, so let's take a look at section 1.6. Okay, this will be our last section in chapter 1. And it is on how we can take two functions we have, combine them together to make a new one. Okay, so we'll show you different ways we can do that. And the big thing we're going to focus on is when you combine them together, you are going to have to figure out the domain and the range. So one way that we can take functions and combine them together is just using one of the 4 basic arithmetic operations. You can add, subtract, multiply, or divide functions, okay, to create new ones. So a very, very simple one would be like, let's say you had the function f of x. And that was 3x. And you had the function g of x. And that was 2x. And if I said to combine those together using addition, the new function you would have is 5x. So 5x is a new function that we created by combining f of x and g of x using addition. And that's basically what we're going to do in this first part. We'll take two functions, combine them together using these different operations. Now, sometimes you don't have like terms. So if f of x was 3x squared and g of x was 2x, not really anything you can do with that. Okay, when you add them together to make a new function, that's all you can do. It's just 3x squared plus 2x. So sometimes we can combine, sometimes we can't. It depends on like terms. Here's the two functions. F of x equals x squared. And g of x equals the square root of x. So I want to take these two functions and combine them in different ways. Let's start with adding. Okay. First of all, are f of x and g of x like terms? No. If they were like terms, you'd have something like x squared and 5x squared, or something x squared and something x squared. The one on the left is an x squared. The one on the right is a square root. You can't combine them. So how do you think we would write the new function, f of x plus g of x? Yep.
X squared plus the square root of x plus 1.
Yeah, that's all you can do. There's not much else. But that's a new function, x squared plus the square root of x plus 1. And it was created by adding the two original functions together. Okay. How about if we wanted to divide them? Well, how do you think I would write the new function, f of x divided by g of x? How about Caleb, what do you think?
That's a really good question.
Wait, what did you say?
I said that's a really good question.
Yeah.
Would you mind saying it again?
How would you write f of x divided by g of x?
Is it not just how it's written right there? Like,
Well, pretty much. What do you think is going to be under this box?
f of x under g of x? That's honestly, in all honesty, that's what I think is under that box.
Okay, at least you're being honest.
Yeah, I just think it's going to be the same thing.
It's going to be the same thing.
Yeah.
Okay, well, we know what f of x and g of x are, so we have to substitute in for them. Yep.
You do x squared divided by the square root of x.
Yeah. X squared divided by the square root of x plus 1. Now, generally, we're not supposed to leave the square root in the bottom. That's not really what we're going to focus on right now, though. So if you got that far, that's fine.
Sorry.
Any question on that? So that's a new function created by dividing the originals. Okay? And there's a lot more examples on page 58, and I gave you guys another example up above. Yeah, up there. So the question is going to be, when we combine them, what is the new domain in the range? Well, let's pretend that f of x, the domain of that, is represented by everything in that circle. Everything that's in the domain of f of x is inside that circle. Well, g of x also has its own domain. And the domain of g of x is everything inside that circle. When we combine the two together, the domain is everything. That didn't work as nice as I could.
We get it. It's a Venn diagram.
Yeah, just go like that. So the domain is everything that's in the overlap. Okay, so when you combine two functions together, the domain is everything that was in the first one and everything that was in the second one. Has to be in both. So the domain is everything that was in both. If you want to think of it like a Venn diagram, it's where they overlap.
Does that include the number that's... If it was like 7 and 9, would it include 7, 8, and 9, or just 8?
So we gotta, like, if f of x was every number, like let's just do a number line. Like, let's say f of x was every number from 0 and up. Let's say that was the domain of one of them. And the domain of g of x was every number from 2 and up. The overlap there is everything 2 and up. That's the overlap. Right. So if you pick any number that's 2 or higher, it's in the black one, and it would be in the red one.
And then if it was any number over 2, you do, what would you pick?
Well, if it was set up like, something like that, now you'd have to say the domain is any number higher than 2, because 2 is not in both of them. 2 is in the black one, definitely, but 2 is not in the red one because it's an open circle. So in that case, the black one and the red one share every single number higher than 2. Okay? Now, one thing we do have to be careful of, especially when we combine functions with division, we have to make sure that we don't do something. What do we always have to make sure we don't do with division? Yeah.
Divide by 0.
Divide by 0. Okay? So when you combine functions with division, you could be creating a fraction where you didn't have one before. If you create a fraction, you need to make sure the denominator is never 0. In addition to what I set up above, the domain has to be part of both. Another thing we want to make sure we never do is take the square root of a negative. So those are just a couple kind of general facts to always keep in mind about domain. No dividing by 0, no square roots of negatives. But I think we've talked about both of those. Okay, so now we'll look at some examples to combine functions again, but this time I want to write down the domain and the range. Okay, so we have two functions, f of x and g of x. And before we do anything with them, to combine them, you want to figure out what the domain is of each one separate. Then when you combine them, it'll be easier. Let's start with the square root of x plus 3. What did we just say about square roots? We want to make sure that we never do what? Yeah. Well, no, not for square root. Not for square root, yeah.
Square root of negative.
We don't want to take the square root of a negative. Okay. That means we want this to always be 0 or higher, what I circled. Now, can anybody tell me, what does that mean you would have to be, or what does that mean you'd be allowed to fill in for x? If we always want this to be 0 or higher. Yep.
I have to think about -3.
No, -4 wouldn't work. Because if you plug in -4, what's -4 plus 3? -1, that's a problem. That'd be the square root of a negative. So we don't want to have the square root of a negative there. Yep.
Anything greater than 3? Or you could do -1.
Yeah, -1 would be fine. So no, it's not everything that's greater than or equal to 3. Yep.
-3 or higher.
-3 or higher, yes. As long as you pick a number that's -3 or higher and you fill it into the top one, you'll be okay.
So
Right,
it can be 0, just it can't.
Oh yeah, you can take the square root of 0. Yep. So I never said you can't take the square root of 0. I just said make sure you don't take the square root of a negative. And 0 is not negative. It's not positive either. How about the domain of square root of x minus 2? What numbers could we fill in for x there to make sure that entire thing that I just circled is always 0 or higher? Yep.
Has to be greater than or equal to 2.
Greater than or equal to 2. Yep. Okay. So that's the domain of each one individually. Now, let's combine them together using addition. Now, when you combine them, they're not like terms. Square roots that are like terms would look something like this. Square root of x plus square root of x. Those are like terms. That's 2 square root x. But since what's under the square root is different in each one, they're not like terms. So how do you think we're going to write f of x plus g of x? Yeah?
The square root of x plus 3 plus square root of x minus 2.
That's all you can do. There's nothing you can combine. So that's your new function. This plus that. And now I want to know the domain. So what I do sometimes is I make a picture of each of the original domains. So here's a number line. The domain of the top one is everything from -3 and up. All those numbers. The domain of the bottom one is everything 2 and up. So the domain of the whole thing is the overlap between the black and the red. What would be the numbers that are part of both? You know, Jack?
2 and higher.
Yeah, everything 2 and higher. Yeah. If you pick any number 2 or higher, it'll be on the red arrow and the black arrow. So that's the domain of the final function. The numbers 2 and higher are in the middle of the Venn diagram. They belong to both. Okay, let's try another one. This time let's do this one. F of x divided by g of x. Okay, first, how do you think we would write f of x over g of x? Get it?
I was just going to ask if you can scroll up just a little bit. Thank you.
Yeah. Yeah. Good. Good.
With the square root of x plus 3
square root of x minus 2. Yep, that's f of x divided by g of x. Okay, so that part, that's the easier part. What I'm more interested in now is the domain. We already know the overlap. These are the same two functions that we had in the last problem. So the overlap is everything 2 and higher. But what's the domain going to be here? Yeah?
Everything over 2?
Why not including 2?
Because then that'd be a square root of 0.
Square root of 0 is okay. Remember I said that before. Square root of 0, no problem
Which would
with that.
divide by 0.
Oh, dividing by 0. Well, that's another problem. So we don't want to divide by 0. If you say the domain is everything 2 and higher, that is the overlap. But the problem is if you plug a 2 into the denominator, you would be dividing by 0. We can't do that. So small change in the domain, but it's kind of important. Okay, this time it's just higher than 2. Yeah. Yep. Any question why the domain was different in that one? That generally happens when you do division. You've got to watch out for divided by 0.
I don't get how like we got x is greater than or equal to 2 and a, because wouldn't you just be able to flip the sign into 3 is less than or equal to x and is greater than or equal to 2?
Can you say that again?
Like, wouldn't you be able to do like 3 is less than or equal to x and is greater than or equal to 2 for the domain?
Well, when you write, they both have to point the same way
Okay.
when you do a conjunction. But a conjunction means you're only allowed to pick numbers between two values.
Okay.
In our case, we're unbounded. We go on forever in the positive direction. So the numbers that you could pick, you could say you could pick anything between 2 and infinity. You could say that. But it's really anything that's greater than or equal to 2.
Is it always going to be one of the domains for both of them?
No, because in this one, this x is greater than 2. That's not this one, and it's not that one.
But for A, would you pick one of those?
For part A in this particular problem, but I guess it depends on what the part A is and the problem. So your answer might match one of those, like it did here, but then it might not, like it did here.
Okay.
Yeah, it didn't match either one of them. Yep.
Can you go over, can you scroll up a little bit?
Yeah.
Can you go over how you got from like the g of x, the square root thing, to the domain? Because I'm just kind of confused.
How we got these two?
Yeah.
So anytime you have something under a square root, it doesn't matter what's in that box. You have to make sure that whatever is in that box is always greater than or equal to 0.
Okay.
So if you take the top one, what's in the box is x plus 3. If you fill that in, and then you get x by itself by subtracting 3 from each side, you get x is greater than or equal to negative 3.
Okay.
And that's how we got that. So just set what's inside this greater than or equal to 0 and solve it.
Okay.
And sometimes it's, it could be a little bit harder to do in your head, so it might actually be helpful to do it out like that. But that's how you do it. All right, so let's try this one. This time they are recommending to graph it, mainly because you are also finding range. And this is a different question, totally different than example 1. So example 2, nothing to do with example 1. So they give us f of x is the absolute value of x, and g of x is x. Okay. How would we write f of x over g of x? Luke?
The absolute value of x divided by x.
Absolute value of x divided by x. Okay. Yep, that's the formula I was looking for. Now the domain. What's the domain going to be in this case? Yeah?
X is greater than 0.
So let's try plugging in negative number and see if that's a problem. Let's do -5. What's the absolute value of -5? 5 divided by -5. -1. So I plugged in -5 and I just got an answer of -1. So -5 was okay to plug in. Yeah.
All real numbers.
It is true that the domain of this is all real numbers. You can take the absolute value of any number you want. And this is just saying, what are you allowed to plug in for x? Well, you could let x be anything.
Anything but 0.
But when you combine them together with division, the domain is anything, yeah?
X is greater than 0 and x is less than 0?
You could say or. X is greater than 0 or x is less than 0. That's definitely one way to say it. Or even simpler way is to say, yeah?
Is it infinite?
Yeah, there are infinitely many answers in the domain. No,
Never mind.
there's infinitely many, but you can't pick any number you want. There is something you can't use. Yeah?
You can't use 0, right?
Right.
So
You
how
can't
would you
use
say
0. So you could say the domain is all reals
Except 0?
except 0.
You just write it like that?
You can write it like that. The way that, was it, Lewis, you had said x is less than 0 or x is greater than 0. You can say that too. Because if you say x is less than 0, you're telling me it's all these numbers. And if you say or x is greater than 0, you're telling me it's all these numbers. But it's never equal to 0. That's the one value you cannot use. And 0 is not a problem here, and it's not a problem here. But it is a problem there because you created a fraction. Right? Now let's look at the range. What did we get when I plugged in -5 for x?
Wasn't it -1?
-1. How about if I plug in -2 for x?
-1.
I get -1. What about -10?
-1.
I get -1. What if I plug in +10? 1. +5? 1. +2? 1. So, what do you think the range is in this case? Yeah?
Y equals 1.
Was there any other number we were getting as an answer besides 1?
Negative.
-1. There's only 2 answers you would ever get in the range in this problem. A 1 or a -1. So the graph of that is going to look very different. It is not going to go up forever and down forever. It's going to look just like that. If you plug in a negative number, the answer is always -1. If you plug in a positive number, the answer is always +1. So in this case, we can list every single number in the range. And this is how we do it. -1 and 1. That symbol means set. It means what I'm about to do is list a bunch of numbers. And I listed 2 numbers, -1 and 1. Now, we don't do that with something like this because, where was it? Right here. If I said to you, list every single number that's 2 or higher, well, how are you going to do that? 2 2.001, 2.04, 2.612, 2.741519. I mean, there's an infinite amount of numbers, okay? So in that case, you can't list them all. You have to just say it's anything 2 or higher. But that one's a little bit different. You can list them all. Okay. Any question on the domain or range of that one? All right, so that's combining functions with division. We did some addition. Let's look at the last way we can combine functions, which is to compose them. Okay. The idea of composing functions is taking one function and plugging it into another function. That's what composition is. So I'm going to show you an example, and then we'll go through how you do it. So here's our two functions. When I compose these two functions together, there's two ways I can do it. I can either plug G into F or F into G. It's two different things. The first way I'm going to do it is I'm going to plug F into G. Okay, so this is G of f of x. So before we even do G of f of x, let's just do something even simpler. If I said to you to find G of 4, what would that mean to do? Find G of 4. Yep.
Plug 4 into x.
Plug 4 in for x in which function?
G of x.
G of x, yeah. Take the 4 and fill it in for the letter in the G formula. So in that case, it would be square root of 4. And then we could simplify it. Okay. What if I said to do G of 25? What does that mean to do? Yeah, same thing. Take what's inside the parentheses and plug that in for the letter in the G function. So look up the G function, square root of x, change the letter to what they're telling you to fill in, 25. It's exactly the same thing when I tell you to do G of f of x. First, look up what this is. What's the formula for f of x in our problem? Yeah?
X squared plus 3.
X squared plus 3. Now I'm going to say what I just said up here, exactly the same way with this. Take what's inside here, plug it into the G formula everywhere you see a variable. Okay. So look at the G formula. It's the square root of x. And everywhere that you have an x, you're going to take that and you're going to fill it in. Because that's what they're telling you to plug in to the G formula. So it's the square root of x plus 3. That's how you take and compose two functions. Now, the second way we can do it is switching around the f and the g. So start with the inside and look up what that is. What is g of x in our problem? Yep.
Square root of x.
G of x was the square root of x. So I looked up what g of x was. Now I'm going to take this, and everywhere that I see a letter in formula f, change the letter to that. Okay, so look up formula f. It's x squared plus 3. But everywhere you have a letter, you're going to change that letter to what they told you to plug in. Square root of x. So we're going to have the square root of x squared plus 3. And what would that simplify to?
X.
No, not just x, a little bit more. For the whole final answer, yeah?
The square root of 2x plus 3.
No, not the square root of 2x. The plus 3 is good though. We definitely want to have that. Yep.
Is it just x plus 3?
X plus 3. Yeah. So remember, when
Cancel out.
you square something and then square root it, those cancel out.
Appreciate that.
So any question how we're going to do some more, but how I did these two. So it's something we have to understand is how to compose them, but the next thing we're going to look at is how do we find the domain of them. It's not that hard, but we have to definitely know how to do what we just did there first. So let's try, I think I got one more I want to try. This is a different way you might see a question worded in the book. I won't be using this notation, a G with a little circle and then an F.
I heard that on final last year.
Oh, you did?
Yeah.
Yeah, I'm going to always be using this notation. It means the same thing. I always use the one on the right. But the one on the left is equivalent. So let's try one more, just before we talk about domain. Let's say f of x was 3x plus 2, and g of x is 4x. And I want you to find f of g of x. Okay. What's your first step? Yep, Julie.
You put the G, like the 4x into that x spot, like 3x.
Can you say it again?
You plug in 4x into the x and you have f of x. Like equation.
Okay, so yeah, first thing I would do is just simplify what is g of x. Okay, we have a formula for that. We can look it up. So what they really want me to do is f of g of x, but that means f of 4x. So now that means in function f, everywhere you see a letter, change it to this. Okay. So we've got 3. We're going to change our letter, and we're still going to have the plus 2. What we're changing this letter to is a 4x. And what would that give me for a final answer? Yeah?
12x plus 2.
12x plus 2. That's f of g of x. 12x plus 2. Okay, so that's how you compose them, but then how do you find the domain? Well, when you compose them, I consider there's an inside function and there's an outside function. I consider that to be the inside. That's the outside. Okay. Inside means it's inside the set of parentheses. Outside is the one that's in front. First thing we have to do is eliminate any values that you are not allowed to use in the inside function. So we're going to think of the 2 steps I'm about to write down. Think of them like a filter. Okay? We're starting with every number. We're going to filter out the ones we can't use. So the first step is to filter out anything that is not in the domain of the inside function. What kind of things would you be filtering out? Is there anything that causes you to divide by 0? Is there anything that causes you to take the square root of a negative? Those are the kind of things you'd have to filter out. Once you check your inside function, then you need to check the composed function. That's the final answer to the problem, like what we did right here. That's the composed function. And then look at that and ask yourself, is there anything I need to filter out of the composed function? So why would you have to filter out something from the composed function? Well, maybe when you wrote them, you created something that has a fraction now. You want to make sure you don't divide by 0. Maybe there's a square root in it. You can't take the square root of a negative. Everybody have those 2 steps? So what we'll do now is we're going to take a look at 2 functions. We'll compose them, and then we're going to find the domain. We're going to do range too, but range we just graph it. So we just have to look at the calculator and see how high and low it goes on the screen. So range, that's always easier if you use a calculator. All right, let's do. I'm trying to find one I want to do. Okay, let's do example 4. I guess we can do it each way. We'll see how much time we have. So they want us to find g of f and f of g. Okay, don't worry about the other notation. And then find the domain of each. All right, let's start with g of f. Okay, what's my first step to find g of f? Yeah.
Turn right to g of x squared minus b.
Yeah, let's fill in f of x. So it's g of, look up f of x, x squared minus 1. So now when I fill this in to function g, what would I get? Yeah.
Square root of x squared minus 1.
So that's g of f of x. Now they want the domain. Start with the inside function. In this case, the inside function was f. Okay, so let's look at f. What are the 2 things we have to be careful about when we're finding domain? We've got to make sure that we never divide by 0. And what else? Square root of a negative. Look at the inside function. Does that have a square root in it? No. There's no square root in that. There's a square. That's totally different. That's the opposite of square root. Okay, so no, there's no square root in function f. Is there a fraction with a letter in the bottom? No. So the 2 things that would be an issue for the domain are not in the inside function. What does that mean the domain of the inside function is? All real numbers. Okay? So from the first step, it didn't do anything. We didn't filter out any values that we're not allowed to use because you're allowed to use everything. Now we have to look at the final answer. All right? So let's look at our final answer. Is there anything here that tells us we might need to be careful? Nico?
Square root.
The square root. What did we say about the square root?
You can't square root negative.
Cannot square root a negative. So that means we want what's underneath it to always be 0 or higher. So what does that mean? That means if we put the 1 on the other side, we have to find numbers that when we square them, they come out 1 or higher. What numbers can you square? And they will always come out 1 or higher. Yeah?
Could you not, why would it not be, why does it x squared have, oh, never mind, no, sorry. Talk about that.
Anybody know what kind of numbers can we square that come out 1 or higher? Yeah?
Over, right? 1 is over.
Yeah, that's part of it. If you want to think of it as like a picture, you could square anything that's 1 or higher. And what else? Yeah?
Is it all numbers except 0?
Nope, if you square like a half, that comes out to a quarter. So no, if you square 1/2, you don't get a number bigger than 1. There are other numbers you can square that will also come out bigger than 1, besides 1 and higher. Yeah?
-1 and lower?
-1 and lower, yes. That's your domain in this one. So the domain is basically everything except this gap in the middle. It's everything except -1 to 1. So the way I would write the domain here is I would say x is less than or equal to -1 or greater than or equal to +1.
Why would you not put on 1 statement?
Because it's an or, that's a disjunction. You can't combine that in one statement. If I wanted to combine it in one statement, I'd have to have 2 dots, and I'd have to be somewhere between the 2 dots. I'm not between the 2 dots. I'm outside the 2 dots. So that's always an or statement. Okay, it's a little tricky. Be careful on that one, but it's a little tricky. Right. Now let's try doing it the other way. F of g of x. Okay. What's g of x? Someone remind me what that was? Yep.
Square root of x.
Square root of x. So let's put that down. And now we're going to fill in the square root of x into function f. Right there. So plug in the square root of x where I just circled. So it's the square root of x squared minus 1. When I simplify that, what does it give me? Yep,
X minus 1.
x minus 1. Now, if all you do is look at the final answer, does that have a square root in it? No. Does it have a fraction with a letter in the bottom that could cause you to divide by 0? No. So you might think all real numbers, but that's not how you find the domain. You have to start with the inside function. What was our inside function here? Yeah.
Square root of x.
Square root of x. What's the domain of that inside function? What numbers are you allowed to use for x? Just right here. Yeah?
X is greater than or equal to 0.
Yes. So from step 1 of finding the domain, we have already filtered it down to everything greater than or equal to 0. So that we're already limited to that. Now we look at the final answer and say, do we have to limit it anymore? And the answer is no. We don't have to limit it anymore because there's no square root here and there's no fraction with a letter in the bottom. So the domain here is x is greater than or equal to 0. But you wouldn't know that just by looking at the final answer. You only know that from looking back at the inside. Any question on that? So always look back at the inside function first, then look at your final answer. So range, well, as I said, we use the calculator. So I'm just going to simplify step 2 to say use the calculator. It doesn't mean you don't have to know how to do the domain. You still need to know how to do that because that's going to set your window. If you don't know your domain, you're not going to be able to set the window on the calculator correctly. So find the domain first, set your window, then you'll be able to get your range. Okay, I'm not going to do both this time. Let's just do G of F. Yeah, that's fine, I guess. Okay, so G of F. Okay, so start by writing what they want you to find. What's f of x in this case? Oh, what's?
Square root of x.
Yep. So fill that in right there. And now what would the final answer look like when we plug square root of x in to formula G? Yeah.
Would it be the square root of x minus 3?
Would the minus 3 be inside the root or outside?
Outside.
Yes, outside. There you go. Yes. Yeah. Okay, so that's composing them. Now let's do the domain. What is the domain of the inside function? Yeah.
Well, I have a question. Why is the 3 outside?
Because you're substituting in this right there.
So it's not like contained
Wait,
inside.
well, hold on. If g of x is x minus 3, wouldn't that include the whole thing then?
So you're taking the square root of x and you're plugging it in for the letter in G.
You're only subbing in the letter.
You're taking this and you're filling it in here. You're not taking all of this and filling it in there. That would be the square root of x minus 3.
Can't leave it on the outside. You can't square it.
Does that make sense?
Sure.
So you're taking the square root of x and you're replacing this letter with what I just said.
Okay.
The minus 3 is not part of what you're replacing. It's just staying where it is. So think of it like this. Fill in that box what I asked you to fill in, which is just square root of x. Okay, so it's the square root of x minus 3.
Okay.
If you do it the other way, then it's different, but we're not this time. Now, what about the inside function right here? What's the domain of that? Yep,
X is greater than or equal to 0.
x is greater than or equal to 0. So keep that in mind. And what's the domain of the final answer? Just looking at what's there. Yep.
X is greater than or equal to 3.
No, you could plug in 2, and you can take the square root of 2. That's okay. Yep.
Less than or equal to 3?
No, you can't take the square root of negative 10. Yep.
Is it 9? Or x is,
Greater than
yeah.
to 9 because it
Which-
is
So when you look at this, you're asking yourself, what are you allowed to fill in right there. That's the domain. What numbers are you allowed to fill in for that x? Yep.
X is greater than or equal to 0.
It's exactly the same as the inside function. You're allowed to plug in anything you want here that's 0 or higher. You're allowed to plug in anything you want here that's 0 or higher. So, well, that's nothing new. It's still 0 or higher. Okay? So the domain here is, if you put both of those things together that we just said, x has to be greater than or equal to 0. Question on that? So it does take a little bit of getting used to finding domain and range, but we'll be doing a couple problems with it. So. Now, when we reflect over any axis, does anybody remember what usually comes up? Like when we did quadratics yesterday? Yeah?
Did we find the range on that one?
Did we do the range? Oh, I'm sorry, I skipped the range. So for the range, just graph
I
it
did not do the range.
and look at how high and low it goes. Square root of x minus 3. How low does it look like that graph goes?
-3.
-3 is the lowest. And what's the highest?
0.
What's the highest?
Greater than or equal to -3.
So yeah, infinity.
Oh.
So yeah, it goes up forever, right? This part's just going to keep going the more I zoom out. Just going to keep kind of going like that. So the range is everything from -3 and up. And because I knew my domain was only numbers that went to the right, I could have cut this part of the screen off right there and not looked at any of that. I didn't need to look at negative x's because it doesn't go in the negatives. But zoom 6 was fine, so I just used it. That's how you do the range. That's it. Okay, so when we do a reflection, what symbol came up yesterday? And I told you this symbol usually means you have a reflection. Yep.
A negative sign?
Yeah, a negative sign. So what I want to do is summarize all the transformations that we learned yesterday, kind of make a chart. And if you see a negative symbol here, it means do this. Negative symbol here means do that. But I'm going to summarize them in a way that's true for any function. Okay, it's not just parabolas or any. It's true all of the time. Okay? A negative will always cause a reflection. It doesn't just have to be a parabola. I gotta scroll down a little bit more. Okay, vertical stretch and shrink, or compression. What letter was that yesterday when we talked about parabolas? The vertical stretch or compression was A. And where was A?
At the beginning.
At the beginning. And what operation did we do with A? Did we add, subtract, multiply, or divide?
Multiply.
Exactly. Whenever you multiply by a number at the beginning, that is always a vertical stretch. Whether it's a square, parabola, that's a vertical stretch for a parabola. There's a vertical stretch for a square root. There's a vertical stretch for an exponential. Anytime you multiply by a number in front of your formula, that will always stretch it vertically. How about a shift up or down? Anybody remember what letter was that yesterday? Yeah?
C.
I know what you mean. I think you're thinking of something else, though. Yeah?
Was it K?
That was our K. And where was the K? Yeah?
The end of the equation?
On the end. And was it added, subtracted, multiplied, divide? It could be add or subtract. Yep. So when you add or subtract a number on the end, it shifts it up or down. How about when we want to shift left? How did we do shift left? Yeah.
Yeah.
We added, and where did we add?
Inside the parentheses.
Okay, it's definitely going to be inside the parentheses, and it's the opposite of what you would expect. So yes, when you add inside, it shifts left. How about if you want to shift right? Subtract. And where would you subtract? Inside the parentheses. Yep. And the last two are the reflections. If you want to reflect over the x-axis, that's a vertical reflection over the x, up to down. Where would you put the negative? Would it go inside or outside? Yeah, it would go outside, out in front of the whole thing. Negative in the front flips it over the x. Where would you put the negative if you want to flip it over the y? Inside. Yep. So now we've got a chart that's going to work for the whole year that tells you how it's going to flip or how it's going to shift, depending on where you add or subtract. So any question on that? So last one. I'm going to give you that picture, and I want you to do this to it. I want you to take f of x and let's do this. So I'm not giving you a formula for f of x. You don't know what the formula is that's making that shape. I just want you to do that to the shape. So you need to know what the plus 2 means. What does the plus 2 mean to do? Yeah?
Shift up to.
Right. If you didn't know, you'd have to look it up. You'd say, all right, adding a number on the end. Oh yeah, shifts up. So all you'd have to do is take this point, move it up 2. Take that point, move it up 2, and same with that one. So I'm just asking you to sketch a picture doing a transformation. And that's it. That's how you shift it up 2. You just have to know plus 2, what it's doing. So that's 1.6. So we'll go over that, and we'll definitely spend a little more time on domain and range from the homework. Okay, so that's homework for tonight on page 66. So we'll go over that first thing, and then we'll finish up all the material for the week tomorrow, and I will put a list of review topics in tomorrow's video.